Hello and welcome. In this video, I'm going to demonstrate how you can perform the Kruskal-Wallis test. The Kruskal-Wallis test is a test you perform when your data violates the assumptions of parametric tests. So it is an equivalent test for the one-way ANOVA. So I encourage you to watch this video to the end so you can learn how you can perform the Kruskal-Wallis test when your data fails normality assumptions. So here is the SPSS file that I have for the Kruskal-Wallis test, and the data had been collected, and you can see that I've got motivation, teaching methods, then I have the gender, and then I have their age group, and then I have the Likert scale that I use to measure the motivation. So in this video, I'm going to go through explaining to you what the Kruskal-Wallis test is and when and why you need the Kruskal-Wallis test. Then to do this, I'm going to use the PowerPoint together. I'm going to alternate the video with the PowerPoint and then the SPSS to explain this clearly to you, and then I'm going to run the analysis using different methods. All right, so I encourage you to watch the video to the end so you can learn more about the use of Kruskal-Wallis test. So let me give you a little context to enable you understand the Kruskal-Wallis test and how you can perform one. So I have this research topic, which is differences in students' academic motivation across teaching methods. The dependent variable as academic motivation, or students' academic motivation, that is the dependent variable. Then I've got the independent variables as the teaching methods. The teaching methods, I have 4 groups. So the first is lecture method, discussion, project-based, and then the blended learning. So these are the 4 ways that I measured teaching methods. So I've got to explain to you that the Kruskal-Wallis test, also called the one-way ANOVA on ranks, is a non-parametric statistical test used when you want to determine whether there are statistically significant differences in the median of a continuous or ordinal variable across 3 or more independent groups. So let me show you that quickly in the SPSS. So in the SPSS, I have got the continuous variable here, which is the dependent variable. Okay, so this is continuous or ordinal. If I come to this point, you can see this is this is ordinal, right? Continuous variables means some variable that is not categorical. It's not like A, B, and C, right? Okay, so and this can be in form of test score, or you can use the Likert scale to measure your dependent variable. All right, but the independent variable here, which is the teaching method, so I've got different categories, right? Just like I explained in the PowerPoint. So you can see that I have 1 as project-based, 2 as discussion, 3 as lecture, 4 as the blended approach. So what are the conditions for conducting the Kruskal-Wallis test? The first one is that you have 1 independent variable with 3 or more groups. Remember, when you have an independent variable with more than with just 2 groups, then you may have to consider the t-test. If the data fails the assumptions of normality or some parametric test assumptions like homogeneity or variance, then you may have to test the non-parametric part aspect of the t-test, which is Mann-Whitney U-test. All right, the subsequent videos I'm going to provide that for you, the test for you. Then the next one is that your dependent variable should be ordinal or continuous, but not normally distributed. So we are going to check out the normality test. So you may have to also check my video down the video description box to see my previous videos on normality test, which I have done, I think about 2 or 3 videos on normality test, so you can check out that to know. All right. 3 is the samples are independent. So in this case, I have independent samples. I have different groups: the lecture method, the practice based, the discussion, and then the other one, right? These are 4 different groups that I have. And then lastly is that the data violates parametric test assumptions. Example, the normality, homogeneity, or variance, like I said before. So what is the purpose of this research? Because one thing is to want to conduct the Kruskal-Wallis test. Another is to understand why you have to conduct the Kruskal-Wallis test. What is the reason? What is the aim of your research? Because the aim of the research should be a guide to the choice of data analysis you're going to perform. So this is to determine whether students' level of academic motivation significantly differ depending on the teaching method used in their classes. And that leads to the research question that you may want to pose in your own research. And it says, is there a statistically significant difference in students' academic motivation across the 4 teaching methods, that including lecture, discussion, project-based, and blended learning? And so how would my hypothesis look like? There are 2 ways to pose your hypothesis. So you can pose the null hypothesis. Usually in group tests, sort of non-parametric tests, you usually want to pose the null and then at the same time pose the alternate hypothesis. So the null hypothesis would be that there is no statistically significant difference in students' academic motivation across the 4 teaching methods, right? But the alternative hypothesis would read that there is a statistically significant difference, that is the alternative of the null, all right? The opposite of the null. That should be the alternative hypothesis. So this is basically how you might want to write it out in your thesis or in your journal article. In this case, I use the Likert scale on the 5-point scale, right? And you can see these are the item statements that I have provided. And you can see, if you take a look at these item statements and you've checked through my previous videos, you will understand that I always talk about personalizing your item statements so that the respondents would ascribe adequate meaning to them. So I just want to explain to you quickly that because I use the Likert scale, 5-point Likert scale here for measuring the dependent variable motivation, I have to group that to have one continuous variable called motivation. So if you don't understand how to do this, there's a video down the video description box, and then check out the video up here on how you can group Likert scale data into continuous variable. That will really help you a lot to learn how I changed these item statements and measure, because the 5 of them, the combination of item statement 1, 2, 3, 4, and 5 gives us these the variable called motivation. Okay, to perform the Kruskal-Wallis test, let us have to analyze. I'll go to non-parametric tests. I'll go to the legacy dialogues, then I'll go to the case sample, independent samples. Then I'll click on it. This is the first step that you can use to perform the Kruskal-Wallis test. However, this approach has a little issue that I will inform you by the time I'm done with this one. So I will select the dependent variable into the test variable list. Then I will fix the teaching method, which is our independent variable, into the group. Now remember, I'm going to define the group. So to define the group, remember you've got the minimum and the maximum. So let me show you what that means. Remember that in the test, we have one as discussion, the problem based. We've got another method as discussion, we've got another method as lecture, we've got another method as blended learning. So we've got 4. So that means the minimum is 1 and then the maximum is 4. So I will click continue. Let me also take you that. If you open this particular box, so you can see that. So the lowest here is 1 and then the highest is 4. Okay, so I will click OK to run the Kruskal-Wallis test. So here you can see that if you take this approach, if you go to analyze and then you go here and then go to this point and use this approach, you are going to have a result like this. And then if you look at this is the ranks, and then it tells us the total number of persons that ticked project based, and then the ranking. It tells us the group that checked discussion, the group on lecture, the group on blended learning, okay, approach. Yeah, and here are the ranks. So when we go to the test statistics here, then you can see that the Kruskal-Wallis H value is 8.021, and then the degree of freedom is 3, and then the significant value is 0.046, and this is less than the 0.05 significant level. So meaning that we will reject the null hypothesis, confirming that there is statistically significant difference in the groups. All right. So one way to do this is that I'm going to copy this and then head over to Microsoft Word and then paste these results. Then pick it up here again, and then I'm going to paste. Okay, because at the end of this video, I'm going to make some interpretation of the results. All right, now if you look at these results, even though that the Kruskal-Wallis test tells us that we should reject the null hypothesis, this particular method did not tell us which of the groups is showing the difference. Where can we find the differences? Okay, we do not have that here. So for you to run that, you need to conduct the pairwise comparison test. And this approach, while I recommend this approach first, is that if you run the Kruskal-Wallis test using this approach and you do not find statistically significant result here, there is no need to conduct further the pairwise comparison test, because it's just like the one-way ANOVA in SPSS. If you do not find a statistically significant result, then there is no need for you to go further to test the pairwise comparison test or the Tukey's HSD test, that is in the one-way ANOVA test. So to check the second approach for running this analysis that will automatically show you the pairwise comparison test, I'm going to head to analyze, then I'll go to independent samples. So this box will open. Okay, here you need to go to the fields and then select the dependent variable into the test field. The teaching methods, which is the independent variable, so goes to the group. Okay, and then you go to the settings and you click customize tests, and then you select the Kruskal-Wallis test. Here, if you want to perform the Mann-Whitney U test, you can use that. In this case, you have just 2 groups, but in this case, we have 4 groups. So we select this and then we run. And so this is the analysis result that you're going to see when you perform this analysis this way. But you can see the result here tells us hypothesis test summary. It tells us that the test is statistically significant, so it said reject the null hypothesis. You reject that because the significant level is less than 0.05. all right, so but there is nothing else that you're seeing right now. So in this case, there are other steps we need to follow. So I will double click here, and that tells me the that gives me an idea about the pairwise, about the independent samples Kruskal-Wallis test, and then gives us this dialog box, and then you can see that I've got some real outliers that is likely making the data not to be normally distributed, all right, or maybe failing the homogeneity of variance test. Now, what do I need to do to conduct the pairwise comparison test? I will have to click here and click the pairwise comparison test. So that gives you an idea about who and who, or which group and which group is actually performing well, that is giving us the statistically significant results, or where the differences are. Okay, so if you look at here, you can see that under the discussion and project-based approach, the sig value is less than 0.005. Okay, so this is why we have to reject the null hypothesis ab initio, right? Okay, but if you want, there's another way that you can provide, you can have a more an easier result that you can quickly interpret. So to do that, then I'll go to edit, I'll go to outline, then I will change this model viewer. I'm going to change that to pivotal tables and charts. Okay, and then I'll click OK. Then I will rerun the analysis again. Then it to produce better results with all the comparison tests together. So I will go back to analyze, non-parametric independent samples, and then I will run again. So you can see that it provides us the non-parametric test, and then you can see we've got the independent samples Kruskal-Wallis test, and then the decision is to reject the null hypothesis. So I'm going to open this and paste the results here. Good. Then I'm going to copy this, paste, so you can see that this is exactly the same test that you've got here before now. You can see this is the same result you've got here. It's the same thing that we've got right now. Okay, and then I'm going to pick the other one if I want. Yeah, so you can see the independent samples Kruskal-Wallis test charts. So you can see we've got pretty large outliers under the blended group, and then under the discussion group, as well as the lecture group. So these asterisks here shows us potential outliers in the data set, and this may be the reason why the test failed the normality and homogeneity of variances test, okay, or assumptions. And this is why we can't quickly use the one-way ANOVA, which is a parametric test, for this analysis. So if we go further, so you can see the pairwise comparison test. So you pick this again and then paste. The next one you need to pick, if you want, is the figure, so you can see where we have the significant result is the difference between the discussion and project based. So let's go back to that again. You can see between discussion and project based, this is where we've got the statistically significant result, and that is exactly what you are seeing here. But if you want, you can pick this, but this is not really important in the analysis. So what is more important is that we've got the result of hold on, let me expand this. So we've got the result of the ranks, so you can report the ranks, and then you report the test, and then the decision is here, and then you have the what we already have above, and then the independent the pairwise comparison test, which is this particular test right now. So let me pause the video and do a little discussion of the findings of the results, interpretation of the results, and write it out for you, so you too can pause your own video to read how I interpreted the results. So let me go through the interpretation once more, and you can actually pause this video to copy this or to screenshot this. This will give you an idea or a guide on how you can write out your own results of the Kruskal-Wallis test. So here it says that the Kruskal-Wallis test showed a statistically significant difference, that is, the p-value is less than 0.05, prompting post hoc pairwise comparisons. Okay, remember that I explained that if you do not find statistically significant result, there is no need for you to go on to do a post hoc pairwise comparison test. The analysis will just end there and you will report what you found. This means that at least one teaching method resulted in a different level of student motivation compared to others. The Kruskal-Wallis test showed that students' academic motivation significantly differed across teaching methods. This is the result, that is, the H represents the Kruskal-Wallis. 3 is the degree of freedom. This is the total number of the participants. So let me show you that again. So you can see the 3, which is the degree of freedom, and into the N, which is the 243 persons that participated in the research, and then the Kruskal-Wallis, the H test, which is 8.021, and then statistically significant. So that is how I presented that result here. The post hoc pairwise comparisons revealed that the project-based learning group reported significantly higher motivation than the discussion group. Okay, and that is where we've got this p-value. If you look at this, you can see this is exactly where we are talking about here. So the project-based appear to have more level of motivation than or when compared to the discussion groups. Okay, and then there is no other significant difference among the groups. This indicates that students exposed to the project-based learning had significantly higher academic motivation than those taught through discussion method. Okay, all other pairwise were not statistically significant because there is no evidence that they differed significantly across the groups. So this is how you can perform the Kruskal-Wallis test in SPSS. I hope you find this video helpful. Please share and like this video, and then comment if you have any difficulty performing the analysis yourself. You can find a way to support you. Thank you so much for watching.